This is Mr. Leach with Simpson Math, and this is the fourth video on exploring algebra tiles. Today we'll be talking about multiplying binomials. This is also a process known as FOIL. We'll talk more about that once we get to the FOIL part, but first we need to do a little bit of review. Before we begin multiplying binomials, let me just remind you a few things about algebra tiles. We have constants with both positive and negative sides. We also have x's with both positive and negative sides. One thing that's going to come into play here is how the length of this x is really sort of trivial. There's no amount of constants that can stack up into n to equal this x. This length is x. But what's notable is that its width here is the width of that constant, and that's by design. So this is our constant, and this is our x, again, both positive and negative. And then we also have x squared. X squared can also be both positive and negative. So what's notable about the x squared is that it is quite literally x squared. If I multiply x times x, we get x squared. Notice it's the area of x times x. So now let's talk about 2 times 3. So as we saw in our previous video, we can model this as saying I have 2 groups of 3. I also barely touched on how we can actually multiply these together, like so. We can model this with an area, where this would be 2 times 3. So we have, this is 2, this is times 3. In a previous video, I modeled how to multiply 2 times 3x plus 4. So in this case, we have 3x plus 4. But we have 2 of them. So I can have 2 sets of 3x plus 4. So if we add those up, of course, we have 6x plus 8. Can we model this like we did with the area model right here? Let me stack these out side by side. And when I do, I get 3x plus 4 times 2. Notice, remember, this is important for this lesson. The width of this x is 1, with this 1 constant. So this is 2 times 3x plus 4. Something I want you to get used to is modeling multiplication with a table. Here I have a constant of 2 times a constant of 3 equals a constant of 6. These 2 algebra tiles times these 3 algebra tiles equals 6. I could quite literally make this a table, like so, and you would see that we would have 1, 2, 3, 4, 5, 6. That's sort of kind of that same idea, just drawn out, but we can do the same thing with the chips. So how can I do that here? So this is quite literally 2 times 3x plus 4. How can I model that? Well, here I have 2 times 3x plus 4. So again, using this area here, I could basically just draw a grid, a long line here, and cut down the lines over where you see that those tiles, and you would literally get 6x plus 8. So let's multiply x times 2x plus 5. Instead of having 2x plus 5 and having x sets of them, which doesn't make sense because I don't know exactly what x is, let's start with the table concept. What you can do as a visual, even before you have algebra tiles, or if you don't actually physically have algebra tiles in your possession, you can even answer this by just wherever you're seeing the lines and the tiles, just sort of kind of drawing a line. That's basically what's going to happen. So what goes here? Well, what's x times x? That's x squared. What's x times x? It's another x squared. Or another way of asking this, what is x times 2x? This is 2x squared. Well, what is x times 5? Well, that's going to be 5x. But you can also ask yourself in a little bit slower process, what is x times 1? 1x. 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 On and on. Or just simply x times 5, and notice that's 5x. So let's put this to paper. This becomes 2x squared plus 5x. In a similar situation, we now have x times 2x minus 5. Well, how can we model this? Well, again, let's start with our table. So instead of a plus 5, it's negative 5. Let's again form our table. This x is our multiply x. So here is x times 2x minus 5 this time. So again, if you didn't have tiles, everywhere you see a line, complete that line. So this time this is going to be x squared plus, is that x? Almost. It's going to have to be a negative x. Remember we talked about when you multiplied a positive times the negative, that sign is going to flip. So all these are going to be negative x's. So with the tiles, it's going to be x squared plus negative x plus negative x plus negative x plus negative x plus negative x. So giving us negative 5x. So this is equal to 2x squared minus 5x. Now, finally, we are to multiplying binomials. I have x plus 3 times x plus 4. Let's arrange this into the table form that we had earlier. So my x plus 3 is x plus 3, and my x plus 4 is x plus 4. So now we're going to multiply x plus 3 times x plus 4. If you don't have tiles, or to save time from just playing with the tiles, one thing that you can do is to draw lines from everywhere you see the gaps here. Notice this big box here is going to be x squared, because this is x times x. Each of these are going to be an x, and each of these are going to be a plus 1. So even without actually physically adding all the tiles on here, you're going to see x squared plus 7x plus 12. Here it is with all the tiles added in. What's nice about seeing this is how it's a tight unit. Notice it is clearly a rectangle. Everything fits in nice and perfect. I don't happen to have one extra one just missing. It's going to be an actual true rectangle. Let's talk about our answer. So I have x squared plus 4x plus 3x plus 12, and I can simplify that down to x squared plus 7x, because those like terms just combine, plus 12. Okay. Here's a very similar question. I want you to pause the video and try this one on your own. So let's check your work. I haven't written the final answer, but I have completed the algebra tile process. So I have x plus 2 times x plus 6. This x times x is x squared. X times 6 is 6x. 2 times x is 2x. And 2 times 6 is this 12. If you haven't yet, use the algebra tiles to find your final answer. As a final answer, you should get x squared plus 8x plus 12. I want you to notice something compared to the last question. Our final answer is pretty similar, but the pictures were a little bit different. We ended up with positive 12 at the end and an x squared at the beginning. And the only thing that's really different is this is an 8x, whereas earlier we had a 7x, which you notice how that definitely does change the picture, but there are going to be some similarities. We're going to talk about some of these similarities in the next video when you talk about factoring, when you go from something like this backwards. So let's take a look at x minus 2 times x minus 6. Here, these are the algebra tiles from the last question. I've done nothing but just move them from one paper to the other. How do I need to change the setup so that way it matches x minus 2 times x minus 6. These plus 2's need to become minus 2's, and the plus 6's needed to become minus 6's. So now that that's changed, what is wrong about our answer here with the algebra tiles? The x squared is fine because this is a positive x times a positive x, which equals positive x squared. Is this wrong? Yeah, this is wrong. This is a positive x times negative 6, so these need to flip over. Remember from previous videos, anytime we multiply a positive times a negative, our answer is going to be negative. So this was fine. This needed to be changed. What about the negative 2 times positive x? Do these positive 2x's need to be changed? Yes, they need to be changed to negative 2. And lastly, what about this last section? Do these need to be changed? No, this is a negative 2 times a negative 6, and remember, a negative times a negative is a positive. So take a second and write your final answer. You should end up with x squared minus 8x plus 12. Pretty similar to the last problem, we just have a negative 8x instead of the positive 8x. So what is different about this question compared to the previous ones? We have a 2x now instead of just x and then an x. So we have a 2x, so that's going to just be a little bit of a difference. Also, we have a positive and a negative. Previously we either saw both positive, or in the last example we saw both negatives. So this is going to be a little bit of a difference again. So think about what's going to be different with our algebra tiles. Instead of just a single x, we're going to have two x's, and then of course that's going to be negative like we saw in the last lesson. Let me grab my algebra tiles and set it up. Okay, so here are my algebra tiles set up. I have 2x plus 3 times x minus 5. If you don't have enough algebra tiles to complete this question, you can always just draw it out using a pencil and paper like I did previously. I'm going to complete each of these 4 sections a piece at a time, so you can do this along with me or check your work in stages. So the x times 2x will give me 2x squared. Then the x times 3 will give me a plus 3x. Now this x times negative 5 will give me a negative 5x. This x times negative 5 will give me a negative 5x. So if I put that together, I'm going to have negative 5 times 2x will give me negative 10x. And then lastly, negative 5 times positive 3 will give us this negative 15. So the final answer is 2x squared minus 7x minus 15, because the negative 10x and the positive 3x will add together to be negative 7x. Looking at the algebra tiles, you want to physically see how we end up with 2x squared minus 7x minus 15. If you take a look, I have this x and this negative x. They become a 0 pair and they cancel to 0. This x and this negative x become another 0 pair and they cancel to 0. And lastly, this x and this negative x become a 0 pair and they cancel to 0. So what we have remaining is 2x minus 7x minus 15. This question requires a lot of algebra tiles, so if you don't have enough algebra tiles, you might want to just use pencil and paper and draw it out. Go ahead, pause the video, and try this one on your own. This one is quite the big one. We have 3x plus 7 and 4x plus 3. I'm not going to write the expressions out to the side right now. I think you're getting the hang of it. So fill in the rest of the table with the algebra tiles. This is quite the big problem, so this is not something that you're going to be wanting to do for every single question you're going to want to get used to the algorithms that we usually use, like FOIL or just basic distribution. So this is just a nice visual tool to make sure you physically understand what's happening and what our answers represent. I'll go ahead and fill in the next sections. See you back in a sec. I've actually run out of algebra tiles myself. So far I have 9x over here from 3x sums 3, and I'm missing a few, so I'm going to draw on the rest with my Sharpie. So now we have 9x plus 28x. And lastly, our constants, we have 7 times 3, which is 21. So we have a plus 21. Put it all together, and you get 12x squared plus 37x plus 21. Alright, two last questions, and these two are a little bit of the special variety. If you notice here, these two binomials have something in common, but something different. What do they have in common? They have the same numbers, but what's different? That middle sign. This is subtraction, this is addition. We call binomials that have the same terms but different sign in the middle conjugates. They're going to do something special when we multiply them together. Go ahead and do it and find out what happens. Here's the first setup. Here's it with 2x times 2x, and we get 4x squared. So, what's special about this one? Here, we have a plus 2x, and then down the bottom, we have a minus 2x. And then lastly, of course, a negative times a positive is a negative, so we have a negative 1. But what happens to those middle terms? They cancel out. They cancel to 0. So we end up with 4x squared minus 1. If you want to see this happen with the algebra tiles, remember, this x and this positive x, they cancel to 0. This x and this positive x, they cancel to 0, and we're left with 4x squared minus 1. It is notable that this is a perfect square and this is a perfect squared separated by a minus. You're going to see me talk about something very similar to this in the next video about factoring. I want to see what you would do with something like this. X plus 4 quantity squared. Give it a second and think about it. If you just thought to yourself, I'll just take the square and square the x and square the 4 and get x squared plus 16. I want you to take your right hand and slap yourself on the back of your left hand. You just watched this entire video about multiplying binomials with algebra tiles, and the first thing you went to was trying just to remember some algebra rule about some square and apply it. And applied it incorrectly. So let's think, how can I physically use algebra tiles to answer this question? Well, first, what does it mean to square something? It means to multiply it by itself. So what's the thing that's being squared? X plus 4. So multiply it by itself. X plus 4 times x plus 4. Now, does that look like something that we've been doing that we can do physical? Yes. Now, use algebra tiles and finish the question. So here's your first setup. Here's your first row. X times x is x squared. X times 4 is 4x. And now for the bottom row, we have 4 times x, which is 4x, and 4 times 4, which is plus 16. Put it together, x squared plus 8x plus 16. This one also follows a pattern. Notice the first and last terms are perfect squared, and the middle term are our two terms in the binomial multiplied and doubled. I hope by you physically seeing what happens when you square a binomial, you won't make that mistake again. So in today's video about exploring algebra tiles, we talked about multiplying binomials, which was also called foiling. I hope you learned something, and I hope this will help. See you next when we talk about factoring.